Wow, amazing. Welcome to the eighth video, still on the force material. Okay, let's continue from where we stopped. Okay, and I think I am going to show you additional image. Okay, here is, as you can see in these images, okay, this is the engine, okay, jet engine. As you can see, hot gases come out of here and the jet is moving, the hot gases move with action force and the jet move forward with a reaction force. Look at these images, look at this one now. You see, these are the hot gases coming out with the action force, and the plane moves with the reaction force. Look at this one too, you see that. Okay, there are many images available online, you can check uh, for additional understanding. Let's go back to our material again. Okay, now the symbol in the problem of rocket can be illustrated in the laboratory. Inflated balloon. If you inflate a balloon, they say if the inflated balloon is pierced with a pin, you have a balloon, you inflate it, and then you pierce it with a pin in one direction and then release it. The balloon will be seen to move in the opposite direction. Okay, now the third application is that Newton's law, action and reaction are equal and opposite. The third law is the reason why walking is possible. Okay, if a man is walking, look at what is happening here. Let's go, please. Wow, wow. Okay, now when you okay, let us read. They say okay, action force exerted by person on the ground. Okay, when you exert the action force in this direction, you are moving forward with the reaction force, as simple as that. You exert action force on the ground and the ground pushes you with the reaction force. This is how walking is possible according to Newton's third law. Okay, we are going to solve a problem here using this law. They say example 6.12. A rocket is burning fuel at the rate of 200 gram per second, meaning after every 1 second, 200 gram of the fuel is burned, okay, to form hot gases, and ejecting all the gas in one direction at the rate of 400 meters per second in 1 second, or let's say this is the velocity of the gas released, and in 1 second 200 gram of the fuel is used. Okay, what is the maximum weight of the or what is the maximum weight the rocket can have if it is going to move vertically upwards? Okay, here is the solution. The first thing they say is mass of gas per second. You have to divide this mass by 1000 to change it to kilogram, because it is given in gram per second. We want to change it to kilogram per second, the correct unit. Okay, in 1 second you have this mass ejected. Now velocity of expulsion is this. Okay, mass times velocity will give us the change in momentum in 1 second. Okay, change in momentum in 1 second is the mass ejected times the velocity. That's the change in momentum. Now, change in momentum per second, according to Newton's second law of motion, change in momentum per second means rate of change of momentum, and rate of change of momentum is the force. Okay, force is a rate of change of momentum according to Newton's second law. So this means that from Newton's second law, we have the force equal to this change in momentum per second. That is why they say the force required equals the weight that you are asked to get here, and you now take the same thing here and put it here. Change this one to Newton. This times this divided by this will give you 80 Newton. As simple as that. Now, inertial mass and weight. Okay, we know that, let me just read. Okay, Newton defined the mass of a body as the quantity of matter in the body. The quantity of matter contained in the body, we call it mass. Okay, measure of mass. From section 6.2, we had seen that inertia is the reluctance of a body to change its state of rest or of uniform motion in a straight line. This follows from Newton's first law. Inertia is thus an inherent property of matter. Okay, what I will say here is this. If a body is at rest, that body wants to be at rest forever. If if anything tries to change it from being at rest to being in motion, it will show resistance. This resistance is what we call inertia. Okay, it will show resistance. If a body is already in motion, is in uniform motion, and then you now that body wants to remain in motion, it doesn't want to be stopped. If anything tries to stop it, it will show resistance. It doesn't want to be at rest. It wants to continue being in motion. Okay, we say it has inertia of motion. When an object is at rest, it has inertia of rest. Now, the thing is, how do we calculate inertia? We don't have a formula for calculating inertia in physics at all, but we can have an idea about it using mass. This is why the same mass of a body can also be defined as a quantitative measure of inertia of the body, meaning that you don't calculate, if you calculate mass, you can have an idea how large or small the inertia can be. The inertia of a body is high if the body has large mass. The inertia is less if the body has small mass. Okay, that is why they say the more mass a body has, the greater the force required to change its state of rest or of motion. So the more mass a body has, the more force that is required to give it an acceleration, because mass is proportional to force, as we can see, and inversely proportional to acceleration. This property of matter is called inertial mass. Inertial mass represents a resistance to any type of force, whatever force. If an object is at rest and a force tries to put it in motion, set it in motion, it will offer resistance. So that resistance, we call it inertia. And the resistance is high when the mass is high. The resistance is low when the mass is low. That is what they are saying. Now, what about the weight? The weight of a body is the force acting on the body due to the earth gravitational pull. The earth gravitational pull on the body is what we call weight. And the formula is this: weight equals mg, where m is the mass of the body and g is acceleration due to gravity. Okay, in the next video, we are going to see, okay, let's conclude this. They say therefore weight varies from place to place, because while mass is constant, the acceleration due to gravity from place to place is not constant, it varies. So variation of g causes variation of w. Okay, but mass, because it's constant everywhere you go, mass is the same, but weight varies because the value of g is not the same everywhere. The value of g and therefore weight is greater at the poles and less at the equator, because the earth is not a perfect sphere. Its polar diameter is slightly less than its equatorial diameter. So at the equator, what they are saying is that the weight at the poles will be greater, and the least value you will get is at the equatorial region. And in the lab, mass is measured with a chemical balance or beam balance. Okay, we measure weight using a spring balance.